Alright, we are going to try again. This is recording number 2, so let's see. I hope this one goes a little better than the first one. So, um, welcome uh, to a video that hopefully will sound okay. I've been kind of trying to figure out this software, but we'll see how it goes. Hopefully, if it's not great, just try and fight through it and do your best. So there are going to be times periodically throughout this video where I ask you to pause the video and do some stuff either on GeoGebra or on your own, like on a piece of paper or anything like that. Please do that. Please actually use the pause button and try and work some things out before advancing through the video. So that way you can maybe actually learn something instead of just sitting there like a vegetable while stuff plays at you. So the first thing I'm going to ask you to do is to either open up a Google Doc, which is probably going to be the easiest way because I'm going to be asking you to do some GeoGebra stuff. Open up a Google Doc, and so that way you can cut and paste, or you can screenshot and paste your GeoGebra images in there, and then also so you can type in answers and that sort of thing to different questions that I'll have for you. Um, so do that, and also I would like for you to get out a piece of paper and a pencil, and just in case you need to write some stuff down or take some notes that Google that might not necessarily go so well in a Google Doc, like equations, that sort of thing. Um, so, without further ado, let's make your way over to GeoGebra, and I have a problem that I'd like for you to work through. First, I want you to make a triangle. So grab your polygon tool and make yourself a triangle. Something that looks like that. Okay? Something that looks like that. Um, then I would like for you to make another triangle that is pretty close to the same thing. Kind of looks somewhat like that. And then play with this bottom point here until you think it looks like a pretty good original triangle, and then a new triangle. Okay, so um, once we have that, then I would like for you uh, to do this, to answer these couple questions. Okay, so let's answer a couple questions. So warm-up questions. All right, warm-up questions. So first, so your three questions are: what rigid transformation will take triangle DBC onto ABC? Now, depending on um, how your triangle looks, your point D might be a little bit different than mine. It might be a little bit out here, might be a little bit in. Just kind of get it close to like there-ish. See if you can make that picture approximately that. Okay. Um, so we want to find out what rigid transformation will take triangle DBC onto triangle ABC. Okay, what rigid transformation will take triangle DBC onto ABC? Explain why point D will coincide with A after that transformation. Let's see, let me put that on there. After the transformation. And is triangle DBC congruent to triangle ABC? Explain your reasoning. Okay, so when you're answering these questions, when you're answering these three questions, I want you to use that sheet that I gave you guys yesterday with all of the transformations on it. Use one of those specific transformation statements to answer number one. Then in number two, use one of those specific justifications statements as to why D will coincide with A. And then for number three, tell me whether it's congruent. Tell me whether they are congruent, and then explain your reasoning. So screenshots would be great for that of you did after you essentially did the triangles land on top of each other. Okay, so I'm going to give you a chance to pause the video and work on this. And I'm going to just be quiet for a couple seconds so that way you'll have time to pause the video without spoiling what's coming ahead. Okay, go ahead, take those, put them in your notes, and I'll be back in a couple seconds. So, essentially, here are a few possible answers for these. So, for the rigid transformation, what rigid transformation? You could reflect DBC across line BC, or you could also reflect DBC across the perpendicular bisector of segment AD. Okay, those would be two options. Okay, um, both of them perfectly valid. Both of them work. Um, so let's try explaining why D will coincide with point A after the transformation. So reflection, after you reflect, the angle is not going to change. The angle measures are not going to change of the triangle you're reflecting. So D prime is going to be on ray BA, since both D prime and A are on the same side of BC. And since those angles are the same on in both of those triangles, instead of going away from A, it'll go right at A. It'll make the same angle at it with B. So then reflection also is going to preserve the length, so that way you can essentially D is going to be that same distance as A as it is from B on the same ray. So A and D, excuse me, A and D should coincide. A and D should coincide because of the same distance along that same ray from point B. Let's take a look at the GeoGebra to sort of discuss how that's going to, or take a better look at how that's going to work. So if we take a look here and we reflect our object, so we're going to use our reflection, we're going to reflect about a line. We're going to take our object and we want to reflect over this line. Now I could have made my point D a little better. Let me actually drag that so it will land a little bit closer to where we want it to be. And nailed it. Okay, so not perfect, but we didn't do any sort of construction, so it's not going to be perfect. All right, so if we take and we reflect this angle ACB is pretty much the same angle as DCB. When we reflect over our line BC, the angle is not going to change when it moves over here. So it's going to land right on top of that other angle. And point D, since it's the same distance from our endpoint B, actually it's showing up as C prime, so it must be endpoint C. Sorry, I think I got them backwards. But since it's the same distance from this endpoint, and it's the same distance from A as this endpoint, then our angle is our point D is going to land the same distance from that as our original point A. So that's essentially what all these words are trying to say. When you flip it, it's just going to land in that same spot. So, um, so, so that brings us to our last question. Is triangle DBC congruent to triangle ABC? And then explain your reasoning. And I mean, it really depends on whether or not you made the picture correctly or we made the picture correctly. At first, when I had my point D kind of a little bit over here, it didn't really, they weren't really congruent. But if we move that point D around, we can make it pretty much a congruent triangle. All right. Essentially, it depends on whether or not you made the picture correctly. If you made the picture correctly, then it'll line up, and then the other one, if you didn't make the picture correctly, try dragging that point D around. It might be a different letter for you, but try dragging that point D around and see if you can make them congruent. Okay? So that's all we were doing for that guy. So let's move on to some new stuff. So the topic for today's lesson is how can we know, what do we need to know in order to say that two triangles are congruent? All right, what do we need to know in order to prove that two triangles are congruent? So before, we said that if we have all pairs of corresponding sides and all pairs of corresponding angles are congruent, then those two triangles have to be congruent. So what we're trying to answer today is, do we actually need to have all that information? Do we actually need to have all 6 bits of information, all 3 sides and all 3 angles? So that's our goal to try and answer today. So what we want to do is we want to start developing some conjectures. What do we need to know? Exactly how many bits of information do we need, and what is that information that we need in order to prove that 2 triangles are congruent? So let's try making a triangle. Before we do that, I would like for you to, if you're not sure how to make specific angles of specific measurements or specific lengths for sides, I want you to take a look uh, at a another video that I'll attach to this, that is attached to this lesson, about how to do that. Sort of a real quick tutorial in GeoGebra. Okay, watch that video if you're not sure, if you don't remember how to make sides that are specific lengths. Okay. Um, So what we want to do is, let's prove that 2 triangles are congruent. I'm going to give you a bunch of information, and I want you to make this triangle in GeoGebra. So here's the information about these, trying to show about this one triangle. Okay, so this is one triangle, triangle ABC. So I want you to make triangle ABC in GeoGebra with these specific measurements. Okay. Um, if it says centimeters, we have centimeters here. I just wanted to give you some sort of unit. Um, just type a 5 or a 2 or a 3.7 in GeoGebra if you are using that information. Okay? So I'm going to give you a second to pause the video, go to GeoGebra, start making that triangle, and come on back when you are done. So let's take a look at how to construct something like this. A couple different ways you can go about it. If you went about it a different way and you still got the same triangle, great, wonderful, that's fine. Um, so the way that I went about this is like this. So first I made a circle with a center and a radius. So essentially I'm going to find my segment AB. So first I'm going to drop my point A, and I know that B is 5 units away from it. So I want a 5 unit radius. Cool. I got my 5 unit radius. Now, it doesn't really matter what direction A goes to B, so I'm going to go ahead and just drop a random point on this circle. Okay. So there we have our points A and B, and if we connect them with a segment, we go from A to B, and we find that our distance, our segment AB, is 5 units long, which is our very first our length information. If we go back to here, segment AB is 5 centimeters. So then we come back to our circle. Next, I want to find the length of segment AC. So segment AC is 2 centimeters. So I'm going to go back to my circle with a center and a radius. I'm going to stay with point A, and I'm going to make a radius of 2. 2 centimeters. Hit OK. Now, point C is not necessarily going to be over here, so we need to figure out what angle point C is going to end up at. So we're going to go into our angle menu, and we're going to find an angle with a given size. All right, find an angle with a given size. So first I'm going to select my leg point, then I'm going to select my vertex. So my leg point is B, my vertex is A, because I'm trying to find angle A, trying to put angle A in there. So angle A is 40 degrees. You can go clockwise or counterclockwise, doesn't really matter. Essentially just whether you want your triangle to be pointing up or pointing down. I'm going to go counterclockwise just because that's how I feel like doing things. So let me get this point B prime out here that we don't really need. But we have our angle A at 40. So let's get a segment that goes out to B prime so we can sort of have that leg going out here. Bam, nailed it. And this intersection right here, that is 40 degrees from angle A, or from segment AB, is going to be point C because it's 2 units away from A. So we're going to go ahead and drop a point right on that guy. So we get point C. And then I'm going to make a segment going from A to C. So that way we can get rid of this segment from A to B prime. So I'm just going to go ahead and segment A B prime. I'm going to click the little button to make it disappear, just because we don't need that whole segment on there. All right. And now, well, what's our distance from C to B? What's our distance from C to B? Our distance from C to B is 3.7 centimeters. So we're going to go back to our circle tool, circle with our center and radius. We're going to click on our point C, and we're going to make a radius of 3.7 units. And we hit OK, and hey look, that circle passes right through B. So we're going to connect from C to B. All right, segment CB is 3.7, just like our circle said it would be. All right, so from here, I'm then going to make sure that angle B is 20 degrees. So I'm going to use my angle tool, just my angle tool. I don't need to have a given size because I have my angle already. So then I'm going to go around point B, or so I'm going to go angle CBA, and I got 20.34 degrees. Okay, not exactly the 20 that we were given, but pretty close. 20.34 is pretty close to 20. And then we're also going to check angle ACB, which is 119.66, which, again, not exactly 120, but still pretty close. Essentially, if we rounded all these, we would get these degree measurements. Okay, so we used all these different numbers. Let me hide some of this stuff so that way you don't have to see all the unnecessary circles. Let's see. Let's play find the circles. So after hiding all of our circles, we get this shape. All right, we get this shape. So we have our segment AC. Segment AC is, wow, I just realized that you haven't actually been looking at that. That's my bad. So I hit all the circles from our shape, and so segment AC is indeed 2 units long. Segment BC is 3.7. Segment AB, which was our very first one that we did, segment AB is 5 units long. And then we have our different angles. Angle A is 40 degrees. Angle B is 20-ish degrees. And angle C is 120-ish degrees. Okay? So, how much of this information did we actually use? Well, we used all of it, right? We measured all of our angles. We did all that sort of stuff. But how much of this information should we need to actually do this? So maybe try making this same triangle again, but try using less information. Try using less information. Okay, try making this triangle again, but try using less information. All right, I'm going to give you a second to pause the video and try making this triangle again. And come on back in a few minutes after you've given it a shot. Again, if you haven't been doing this, you need to start taking screenshots every time you're done with a task that I'm giving you. So once you're done with this, making this again with trying to use less bits of information from this list, take a screenshot of what you came up with and put it in your notes. Okay? Be right back. Hopefully you're able to find out that you don't actually need every single bit of information to make any given triangle. If we didn't actually label those angles, we still would have had our triangle. We also didn't need to connect segments BC with a circle that is 3.7 units long. We actually only needed a few bits of information. Like 3 or more is generally the magic number. And so if we don't need every single bit of information about a triangle to make a triangle and to make an exact copy of a triangle, then hopefully it makes sense that we wouldn't need every single side and every single angle to prove that 2 triangles are the same. If we can copy a triangle with less than 6 bits of information, well then we should be able to prove that 2 triangles are congruent with less than 6 bits of information. We don't need to prove every single side and every single angle is congruent in order to prove that 2 triangles are congruent. We just need part of that information. So now I'm going to give you some information about a few different triangles. In between each of these, I would like for you to pause the video and try and construct the triangle. Then I want you to say how many pieces of information you needed and what was that information that you needed. If you needed multiple sides, tell me that you used two sides. If you needed two angles after that, then you also needed two angles. All right? I want you to tell me how much information you needed of the information I'm going to give you, and what is the least amount of information that you need in order to assemble one of these triangles. Okay? So I'm going to pause, put a bunch of text up here, and this will be triangle 1. So here's your information for triangle number 1. Triangle number 1. Oh, hey, thanks, Caps Lock. So what I want you to do is try and construct triangle number 1, and I want you to see if you can figure out what is the least amount of information that you need, and then what was the information that you used. All right, what is the least amount of information that you need in order to construct this triangle to make all these things true, and what was the information that you used in order to make it. Okay, so that's triangle 1. Take a second, pause the video, and see what you can come up with for your construction. So here's what I came up with after some value changing and what things are displaying and all that sort of stuff. I came up with this after moving some points around and doing all that sort of stuff. Got these guys to line up. This is the triangle I came up with. Hopefully you came up with a triangle that is the same. Could be a little bit different in the depending on what you used, depending on what information you used. Again, what information did you use, and what's the least amount of information that you used? Those are the important questions that I want you to try to answer here. Hopefully you got this triangle. And so let's try another triangle. Let's try another one. And again, I realized I forgot to actually show you the triangle. Wait, go Mr. Seja. All right, yay, new software. So hopefully your triangle looked like this. If it didn't, maybe check your numbers again. Check and make sure that you're putting things in correctly and drawing things correctly. One thing I just found, feel free to use the segment with a given length. Use that one to make my sides, and then I use my angle tool to measure those angles. Um, so again, what information did you use, and what was the least amount of information you could have used? Okay, so here we will come up with I'll show you another triangle, and you can work on that one. So that's triangle, and we'll take a look at triangle 2 here. So as promised, here is triangle 2. Give triangle 2 a shot again. See what information you used, and try and use the least information possible. If you used more than 5 bits of information to construct the triangle, I want you to try and see if you can do it with less. Try it again. See if you can do it with less than 5. Okay. All right. Give this a shot. See what you can GeoGebra up. All right. I will pause the video, and you should do the same. Alright, so with these constraints, here's what I came up with. Triangle 2, I came up with this guy. The side lengths are a little weird. This time I made sure I made the angles first, and then I made the sides. So, a couple different ways to go about this. Hopefully you came up with something similar, something that looks really, really close to this. It might be rotated, might be, different positions, that sort of thing, but that's okay. They should all be congruent. We had the same information. Again, how many bits of information did you use, and what were those bits of information? Okay. So take a look at your last two triangles and see if there was anything in common. We want to start being able to make some conjectures about these ideas, about these different triangles, and what kind of how much information we actually need in order to make these triangles congruent. or make these triangles. Yeah, how to determine what we need in order to make a triangle. Because if we know how much we need to make a triangle, then we know how many bits of information we need to say that this triangle is the same as this other triangle. Okay, so make a couple statements, make a couple conjectures as far as you think this is the amount of information that I need in order to. This is the least amount of information that I need in order to make a triangle. And what is that information? What are those information? Are they sides? Are they angles? Are they some combination of sides and angles? What sort of thing are we looking at? Okay, take a second, jot some notes, jot some ideas down, jot a few conjectures down as far as I think this is the information that I need in order to make a triangle. Okay, pause the video and make some guesses, make some conjectures. So, so of the bits of information that we have access to, we have three sides. We have three sides, and we have three angles. Of those sides and angles, we really actually need three total bits of information. So hopefully, you will have found that of those three total bits of information, let me see here, let me format this a little bit nicer. Yeah, there we go. Of those total bits of information, there are some specific groups. All right, so if we have three sides and three angles, well, we could have three sides. We could have three sides, or we could also have two sides and an angle. Whoopsie daisies. What did I just do? Here we go. Three sides and an angle. Or two sides and an angle. Or we could have so two sides and then an angle sort of on the outside of those sides. So it would be a side, then another angle. Or we could have a side, and then instead of an angle on the outside, we could have an angle on the inside. We could also have um, a side and two angles. Typing is the hardest thing in the world to do. We could have a side and two angles. So a side and then two angles going around our triangle. We could have an angle and a side and then another angle. Or we could also have three angles. Okay, so those are the possible three bits of info that we can have. So what I mean by all these three bits of info, so we could have all three of our sides, side 1, side 2, and side 3. So I actually just realized that I'm not sure if you can actually see my cursor. So we could have these three sides. So all three of these sides, okay, this should work. I'm hoping it does. Because I can't see the preview window for what I'm working on. But okay, so for side, 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 essentially, that's having all three sides of information: side one, side two, side three. For side, side, angle, we're going to have two sides. So we're always for each of these, we're going around our triangle. Okay, so if I start with a side, I'm going to start with a side, and then I'm going to go to another side, either this way or this way. So I have side number one, side number two, and then the next angle. Okay? Or side number one, side number two, and the next angle. Or any sort of combination, any sort of like however you can go a side, and then an angle that's attached to it. Any of those bits of information would fall into that side-side angle category. Um, and these guys have abbreviations, um, which are really useful because that's a lot of stuff to talk about. Um, so there's those abbreviations. Do me a favor for the side-side angle one. Um, don't don't do angle side side. That's just rude. All right. Don't do the angle side side abbreviation. It's a terrible idea. Um, so side angle, or if you have side angle side, that means you have a side, an angle, and then another side. You have to go consecutively around your triangle. So side, angle, another side, angle, another side. So you're going all the way. You're going around your triangle either clockwise or counterclockwise, whichever you prefer. Um, but make sure that you're going in sequence around your triangle. So like for side angle angle, you'd have a side, an angle, whoopsie daisies. You'd have a side, an angle, and then another angle. Side, an angle, and another angle. Um, or a side, an angle, another angle. Okay? Um, so that's another option for information. Angle, side, angle. We could have angle, a side, and an angle. Angle, a side, and an angle. Or angle, side, and an angle. Okay? So a side in between two angles. Or we could have all three angles. Okay? In actuality, the three that we want to really pay attention to are side, side, side. That can that will determine a unique triangle for us. Side, angle, side will determine a unique triangle for us. And angle, side, angle. These are the three that we can use to actually create a triangle, without any other information. Those are the three. Um, with the other three, we'll need at least one more bit of information other than just that. Okay, um, so give it a shot. Take all those bits of information, and draw the triangles using those three bits of information. Either all three sides, all three side angle inside, or a side with an angle in between. Yeah. Let me try that with English. You could do a side with an angle. Man, words are hard. You could do two sides with an angle in between. There we go. I got there one time. Two sides with an angle in between, or you can do two angles with a side in between. All the other three will not be able to work. Okay? So go ahead and try one of the last two triangles with just these three bits of with just one of these three groupings of information. Either all three sides, all three angles, so a side, an angle, and a side, or an angle, a side, and an angle. Okay? Give that a shot. See what you come up with. See if you can make it happen. So, let's take a look at one of the other three scenarios. What if you were told that you have one angle that's 16 degrees, one side that's 5 centimeters, and one side is 4 centimeters? Here we have the angle side side, which is never the order that you should say that in, the angle side side information. Okay? Um, what kind of triangle can you make? Can you make a triangle with just that information? See what you can come up with. See if you can see in GeoGebra what you can make happen. Okay, give it a shot. I'm going to pause the video. You should make these in GeoGebra. So if you made a triangle with this information, you could have gotten a couple different triangles, a couple different options. All right. Um, I'm thinking that you may have gotten something like this, or you could have gotten something like this. So if we go back to the information that we were given, one side is 5 centimeters, one side is 4 centimeters. So we have a five-sided, uh, 5 centimeter side and a 4 centimeter side. In this triangle, we also have a 5 centimeter side and a 4 centimeter side. We also had a 16-degree angle. Okay, a 16-degree angle. And in this guy, we have a 16-degree angle. And in this guy, we have a 16-degree angle. Now, um, why does that happen? Well, because we weren't specific, we weren't super precise about where that angle lives. All right, where this 16-degree angle lives. So, um, if we have this information where we have two sides in an angle, we need to make sure we are 100% clear as to where this angle is. Um, it would be a lot better to say, all right, one angle is 16 degrees, um, one side's 5 centimeters, one side's 4 centimeters, and that 16-degree angle is in between the 5 centimeter angle and the 4 centimeter, or the 5 centimeter side and the 4 centimeter side. So we want to make sure that we're specific about where these angles are living. Okay, um, so make sure that when you are asking and trying to find out that information, that you're paying attention to where that information is. Again, because if we go around those triangles, we can have very, very different results with based on where those different angles are located. So let's go ahead and wrap up today's lesson. Let's wrap up today's topics of things that we are talking about. All right. So our goal is to make statements as far as how we know two triangles are congruent. Okay, if we know that all the parts of those triangles have to be congruent, then we want to find out what is the least amount of information we have to figure out, we have to find in order to show that they are congruent. And the less information we have to find, the better, because that means less work for everybody involved. Okay, less work is good. All right, so we want to find um, we want to find some statements that can uniquely determine some triangles. Okay, that you can uniquely determine triangles. First, if we have two pairs of corresponding sides that are congruent and the angle in between those sides are congruent. Okay, so if we have one pair, two pair, and the angles between them, those are congruent triangles. That's enough to say that those two triangles are congruent. Okay, these would be really, really good to copy down in like a glossary in that in your sort of key terms page, key terms area, or your vocabulary worksheet, or whatever, or your vocabulary page, or glossary, or whatever you want to call it. Um, so this is side, angle, side, side, angle, side. As we go around that triangle, it's side, angle, side information. Side, angle, side. So side, angle, side is congruent triangles when two pairs of corresponding sides are congruent and the angles between those sides are congruent. That's side, angle, side. The other statement that we can make, that we can have to uh, determine whether or not triangles are congruent. Excuse me for 1 second. Okay, just want to make sure we were still recording. I'd have felt really bad if we weren't. So the next thing that we have is if we have two pairs of corresponding angles that are congruent and the side in between those angles are congruent. So we have congruent angle, and a side in between it. This is angle, side, angle information. Angle, side, angle. Okay? So first we had side, angle, side with these two guys. Then we have angle, side, angle with these two guys. If we know that two pairs of corresponding angles are congruent and the side in between those corresponding angles are congruent. The last thing that we can have is if we have all three sides, we know all three sides are congruent, uh, all three pairs of corresponding sides are congruent, then we can say that the triangles are congruent as well. So, side angle side is enough information. Angle side angle, so two pairs of corresponding angles are congruent and the sides in between them are congruent. Or if we just know that all three pairs of corresponding sides are congruent, that's enough information to show that the entire triangle is the same. Okay? All right. That's everything. You have a homework assignment tonight. Do your best on it. We are going to talk about all of these things tomorrow. We're going to talk about your homework assignment tomorrow and a couple of these ideas. So do your best. I hope this worked. I apologize for all the sort of technical glitches if and when you find them. But I'm proud of you for hanging in there, and I will see you guys tomorrow. Have a great night. Bye.